Hello, dear students. I hope you are understanding the chapter we had learned till now. What are acid and bases? What is the meaning of strong acid and bases? pH and its importance in everyday life. Now, today we are going to study about salt. You had already learned in this chapter about neutralization reaction. When an acid reacts with a base, it forms the compound called salt. Salts are ionic compounds which are produced after neutralization reaction between acid and base. Salts are electrically neutral. There are a number of salt, but sodium chloride is the most common among them. Here, ionic compound means the compound which are formed by ions. These ions are formed by the loss or gain of electron. We are going to discuss this in detail in the third chapter, metals and non-metals. Let us now study the next topic, family of salt. As there are large number of salt present, so we can categorize them into family of salt. Salt having common acidic or basic radicals are said to belong to the same family. Acid or basic radicals. Radical means an atom of an element or a group of atoms of different elements that behave as a single unit with a positive or negative charge on it. Let us see some example. Chloride family. Sodium chloride, calcium chloride belong to this group. Calcium family. Calcium chloride, calcium sulfate, etc. belong to this family. Zinc family. Zinc chloride, zinc sulfate, etc. belong to this family. Salt can be categorized as acidic, basic, and neutral salt. What are neutral salt? Salt produced because of reaction between strong acid and strong base are neutral in nature. The pH of such salt is 7. For example, sodium chloride. As we already discussed this reaction, when strong acid like hydrochloric acid and strong base like sodium hydroxide react together, they form the salt sodium chloride, which is neutral. Let us see what is acidic salt. Salt which are formed after the reaction between a strong acid and weak base. The pH of acidic salt is less than 7. Example, ammonium sulfate, ammonium chloride, etc. Here you can see the example. Ammonium chloride, an acidic salt, is formed when the reaction takes place between hydrochloric acid, a strong acid, and ammonium hydroxide, a weak base. You can see the reaction here. Ammonium NH4OH reacting with hydrochloric acid HCl, forming ammonium chloride and acidic salt. Now let us see what are basic salt. Basic salt are formed after the reaction between weak acid and strong base. The pH of basic salt is more than 7. Let us see the example of basic salt. Sodium carbonate, sodium acetate, etc. You can see here the reaction taking place between sodium hydroxide, a strong base, reacting with carbonic acid H2CO3, a weak base, forming sodium carbonate, a basic salt. I hope this is clear to you. So let us begin with the next topic, chemicals from common salt, that is sodium chloride. Here you can see the reaction taking place between sodium hydroxide and hydrochloric acid. Sodium, as you can see here, is positively charged. Hydroxide OH is negatively charged. Hydrogen in HCl is positively charged and chlorine is negatively charged. Na positive combines with Cl negative to form sodium chloride, a neutral salt. Sodium chloride is called rock salt, as they are obtained from minerals called rock salt. Beds of rock salt were formed when seas of bygone ages dried up. Common salt is used in making various materials like sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Let us see the preparation of sodium hydroxide, chlorine, and hydrogen gas from sodium chloride. The process is called core alkali process. When electricity is passed into an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide. In this process, chlorine gas is evolved and given off at the anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. This process of electrolysis of sodium chloride is called chlor-alkali process, as one of the product formed is sodium hydroxide and alkali and the other product is chlorine. Here you can see the reaction which is taking place. Sodium chloride, when undergo electrolysis, it dissociate into ions and then the reaction take place forming sodium hydroxide, chlorine gas which is deposited at anode and hydrogen gas which is deposited at cathode. Let us now see the uses of chlorine gas, hydrogen gas and sodium hydroxide. These materials obtained by the electrolysis of sodium chloride are used to make many other compounds. Uses of chlorine as an antiseptic, for cleaning the drinking water, treating the swimming pool to kill the germs, in the production of paper, dyes, medicines, plastic, paints, etc. Now, let us see the uses of hydrogen gas. It is used in the hydrogenation of fats and oils, as a rocket fuel, for welding purpose, in the production of hydrochloric acid, etc. Let us now see the uses of sodium hydroxide, commonly known as caustic soda. It is used in a wide variety of industrial sectors, in pulp and paper processing industries, for bleaching purpose, in de-inking of waste paper, and in water treatment. It is used in the industries like textile, where they are used to process cotton and synthetic fibers. Caustic soda is also used in soap and detergent industry. It is used in oil and gas industry, in household cleaning products, in beverage bottles, in home soap making, etc. Let us now study the manufacture and uses of bleaching powder. Chemically, bleaching powder is calcium oxychloride. The formula is CaOCl2. Let us see its preparation. Bleaching powder is produced by the action of chlorine on dry slaked lime, that is calcium hydroxide. You can see here the equation taking place in the formation of calcium oxychloride. You can see here the equation calcium hydroxide reacting with chlorine to form calcium oxychloride, that is the bleaching powder. Now let us see the uses of bleaching powder. Bleaching powder, one of the most important compound used in various fields. In bleaching the cotton and linen in textile industry, for bleaching wood pulp in paper industry, for bleaching the washed cloth in laundries. It is used as an oxidizing agent in many chemical industries, and it is used for disinfecting, that is, to kill the germs in drinking water. Let us now study another important compound, baking soda. We'll study its preparation, properties, and uses. So, starting with its preparation. Baking soda can be prepared by the following process. When sodium chloride react with water, carbon dioxide and ammonia, it forms the compound sodium hydrogen carbonate, commonly called as baking soda, along with ammonium chloride. Here you can see the reaction taking place in the formation of sodium hydrogen carbonate, that is baking soda. Let us now see the properties of baking soda. Sodium bicarbonate is white crystalline solid. It is alkaline in nature, having the pH more than 7, and it is a mild non-corrosive base. Another property, when sodium bicarbonate is heated, it gives sodium carbonate, which is commonly called washing soda. Now let us see the uses of baking soda. Baking soda is one of the most important ingredients found in each and every kitchen. Baking soda is used in the preparation of baking powder, which is a mixture of baking soda and a mild edible acid such as tartaric acid. Baking soda is used as one of the ingredients in antacid. It is also used in soda acid fire extinguishers. I hope the topic which we have discussed today is clear to you. There are some more compounds which we have to study, and we will be continuing that in the next video. Till then, take care of yourself. Thank you.